All right, so we're wrapping up a little bit of the custom work on the 5130-100. I'll show you guys what I'm about to do with our CNC plasma cutter real quick. You can come over here and check this out. The whole theme of this build is supposed to be a little bit like an era appropriate, late 50s, early 60s hot rod, like muscle truck kind of build. So we want to keep it true to its nature. It's keeping the straight axle. Customer didn't want to just cut off the front end and put a Mustang 2 coilover kit or anything. Wants a straight axle, but he wants to be able to do 75, 80 miles an hour. So we did power brakes, power steering, and kind of cleaned up some of the geometry a little bit, but he wants everything to look like it's still a 51. And so part of that, what we want to do is retaining the original bracketry. This is a cast steel bracketry that came off a small block Chevy that, not this small block Chevy, this is a hydraulic roller, but we're going to kind of dress it to look more era appropriate. Well, one of the issues we're having is this car has a vintage air kit, and we've got our sand and compressor here, and it so far went right up. Phil's got some of the geometry largely worked out, but we need a tensioner for it now, and so that's what I'm going to get cutting on the CNC plasma, and I'll give you guys a little demo of what I came up with here. And so I drew this in CAD. This is Fusion 360, and you can see this right here is that bolt hole where it will tension. This is what we're kind of looking for here. It's just that ability to pivot on that bottom one so you can tension the belt or release the belt and put it back on. That's our piece there. So that's what we're about to cut out, clean it up, bolt it up, and see how it fits, see how it works. We're gonna be a couple other cuts. You know, we're cutting some washers and some pieces for a steering column. We've got a rear shock mount for this truck in the works too. These are some braces that we got to cut. Always put like a little hole in some of this stuff wherever I can, and that helps with basically warping. It's not so much about like whether this truck needs to be lightweight or anything, but you sometimes putting this heat, you know, or this hole in it helps with warping when you weld things, and it kind of helps alleviate some of the, you know, distortion. Head over to the plasma cutter. We'll cut this stuff out, and then we'll clean it up, fit it up, and see how it looks. And if it looks good, then we'll stick with it. But sometimes this is like a little bit of an iterative design process. Sometimes you got to kind of come back and do it again. Post-process our design here. Plasma cutter's set up pretty well where we want it to. All right, so we got the G-code file for the tensioner pulled up right here. We'll go ahead and run a dry run on this first one, just make sure we're not gonna interact with anything. What'd you do, Brady? It's not working anymore. I think this like little controller's going out on me. It's been having troubles lately. Who knows, man? We're gonna, I guess, run it raw dog, no lid. We'll get our work coordinate system 0 set to do a dry run. We're just making sure everything doesn't go outside the lines or onto any cuts that we've already made in the material first. It looks like it's gonna be good. Yep. I think we're good. All right, watch yourself. Might as well just try to cut it again. That's wide open. Just slow it down. All right, watch your eyes. one looked a lot better. There you go. Still pretty hot. We can go check our geometry. All right. That's gonna work. All right, we'll clean it up, bolt it up, get our hardware, and actually confirm that it works, but it looks pretty good.
Looks damn good.
Yeah, not bad, pretty quick. Get the dross off it, it's good. We got a couple more things we gotta cut. You wanna see that or what? Yeah. All right. Got to do 4 of these. It's cutting good now. It's barely gonna fit. Cool. I think the plasma cutter's done. It's like one of those like prosthetic arms. Have you ever seen the movie Kingpin? You're probably being too impatient. I end up getting burnt. Yeah, I'm just gonna wait a minute. Everything's hot. All right, Riley's pulling the shock mounts off the 3100. These are the gussets for it. We already got them fitted up on the car with the shocks and set down and everything. You know, they're good. Everything's good on it. So now we know they fit. Now what we need to do is weld on the gussets that just kind of give that extra support. And then we can go ahead and bolt them back on. How'd that thing clean up? That looks pretty good, huh? I'd be surprised. I mean, I'll be happy. I wouldn't be surprised, but I'll be happy if that's a first time go. So when you're doing CAD design, you have to think of it like a sketch pad, except for it's 3-dimensional. So, you know, everything in CAD is relative to something else. So you start with what's called the origin, and that's kind of like the center. So you have your Z axis, your Y axis, and your X. And then you have the origin point. And then everything that, you know, in your G code, which controls these CNC, whether it's the CNC mill or the CNC plasma, is relative to that 0Z, 0X, 0Y. And so basically, if you think about this whole room populated with pixels, which are each assigned a little coordinate, you have to say, like, you know, I want a straight line from this particular pixel, which is located at this many up, this many over, this many left, right, and then it will give you that exact coordinate. And then you'd want to tell it that you need to move to here, which is this, and then this is the path you take by hitting all these other pixels along the way. And so it kind of can like bend your mind a little bit when you get into this 3-dimensional stuff. Like, even though we cut it out on 2D, the bracket system has 3 dimensions. and the way the measurements are on 3 different planes. And so it's kind of like, you know, you can, if it works out the first time, I'll be pretty happy with that. If I have to make some small adjustments, I kind of expect that, because it's like you're using a set of calipers and you're kind of like trying to, you know, put your finger here and use it like a straight edge to meet this and that. And then we need something for that next. Okay. Originally being the inline 6, we had to clearance these, and because the V8 sits further forward in here, even though we couldn't push it too far back because we didn't want to modify the firewall. But I mean, it's still at least 80% of that engine's behind the front axle, so that's good, right? From performance and handling aspect, you want it nice and far back. You don't want it coming too far out. Maybe in a place where we have to pop the valve cover in order to put the belt on the alternator, but that's not that bad. This small block Chevy in particular just uses 4 bolts right down the center of the top of the valve cover. So I'm okay with it. If that's what we got to do to change the belt, I don't think that's that big of a deal. You just pick it up and lift it and move it, but ideally you don't have to. We want the builds that we do here to be easy to work on also, not just look badass and, you know, be functional. You know, you want ease of maintenance whenever you can, but you do have to compromise in some instances. But I mean, it's not uncommon to have to lift the valve cover on small block Chevys occasionally in order to get the belt on, especially in tighter engine bays. All right, we'll get working on the alternator bracket now. Cool.